You've been told these are the planes that won World War II. Iconic silhouettes, museum pieces, legends. But here's what they don't tell you at the air show. Before these machines became legends, they were graveyards. And the brass, they knew it. The Corsair, pilots called it the Ensign Eliminator. The B-26 Marauder, the Widowmaker. The B-29 Superfortress, the most advanced bomber in the world, almost incinerated its own factory because someone ignored a fuel leak. These weren't battlefield losses. These were design flaws. Flaws that engineers flagged. Flaws that test pilots screamed about. Flaws that killed men in training, not combat, because High Command decided the war couldn't wait for a fix. So today, we're pulling back the curtain. 4 warplanes, 4 cover-ups, and the men who paid the price while the Pentagon looked the other way. Let's start with the Corsair, 1940. The Navy needs a carrier-based fighter that can outrun, outclimb, and outgun anything Japan throws at it. Vogt Aircraft delivers the F4U, a beast. On paper, it's a masterpiece. That inverted gull wing, not just aesthetic, it's engineering genius. It shortens the landing gear, reduces drag, and increases clearance for a massive propeller. The long nose houses an engine so powerful it could drag this thing through the stratosphere. The promise? A fighter so dominant it would sweep the Pacific. The reality? The Corsair couldn't land without killing its pilot. See that long nose, the one stretching out like a spear? It made it look intimidating, but it was a death trap. On carrier landings, the pilot can't see the deck. He's blind. Worse, the plane's center of gravity is so far forward that when the wheels hit, the nose slams down, the wing stalls, and the entire aircraft cartwheels. One Navy test pilot, after 4 attempts to land this thing, walked into his CO's office, looked him in the eye, and said, "This airplane is going to kill me." He wasn't wrong. Now meet the B-26 Marauder, 1941. The Army Air Forces need a medium bomber that's fast, heavily armed, and can strike deep into enemy territory. Martin Aircraft delivers a plane with a 315 mile-per-hour cruising speed and a 3,000-pound bomb load. But there's a problem. To achieve that speed, Martin gave it short, stubby wings. High wing loading means high landing speed, 140 miles per hour on approach. For context, a B-17 lands at 90. And if one engine fails, you don't glide, you drop. In 1 month at MacDill Field in 1942, 15 Marauders were written off, not shot down, written off in training. The accident rate? 165 for every 100,000 flight hours. That is more than double the rate of comparable bombers. Crews started calling it the Widowmaker, and brass? They kept building them. Okay, let's zoom in. The Corsair's landing gear. Simple, right? A hydraulic strut absorbs the impact, springs compress, energy dissipates. The plane settles onto the deck. In a perfect world, this works, but you're not landing in a perfect world. You're landing on a 500-foot-long platform moving at 25 knots. The deck is pitching 15 degrees. There's a 30-knot crosswind. You're coming in at 85 miles per hour, blind because that long nose blocks your view. You can't see the landing signal officer. You can't see the arresting wires. You're flying on faith and muscle memory. And then you hit. The gear compresses, but not enough. The springs weren't designed for this kind of abuse. The nose bounces once, twice, and then the wing stalls asymmetrically. The plane rolls onto its back, slides into the ocean, and sinks in 90 seconds. The pilot? If he's lucky, he's unconscious. If he's not, he's upside down, underwater, trying to unbuckle a harness with freezing hands while seawater floods the cockpit. One pilot described it this way: "You don't train for this. You train to fly. You train to fight. But nobody tells you that landing this thing on a boat is like throwing a brick at a moving target and hoping it doesn't shatter." And the Navy's response? They grounded it, pulled it off carriers entirely. The Corsair, the plane built to dominate the Pacific from the decks of carriers, was banned from carriers. Meanwhile, at MacDill Field, Florida, the Marauder is eating crews alive. The problem isn't the plane's speed, it's the training, or lack of it. Pilots transitioning from lighter bombers weren't prepared for the B-26's handling characteristics. Engine out on takeoff? You had seconds to react. If you didn't immediately feather the dead prop, trim the rudder, and firewall the good engine, you were in an unrecoverable spin. And here's the kicker. Martin knew this. Test pilots at Wright Field flagged it in early trials. They recommended extended training periods, better engine-out procedures, and higher approach speeds. Brass ignored it. Why? Because the war couldn't wait. Factories were pumping out B-26s faster than they could train crews to fly them, so they sent them up anyway. The soldiers knew. One crew chief wrote in his diary, "Every time one of these goes up, we stand on the tarmac and count. If it comes back, we breathe. If it doesn't, we write letters." February 18, 1943. Boeing's Factory Airfield, Seattle, Washington. The B-29 Superfortress is about to make its second test flight. This is the plane that's supposed to end the war. Pressurized cabin, remote-controlled gun turrets, a 3,000-mile range. It's the most technologically advanced aircraft ever built. But there's a problem Boeing's engineers flagged weeks earlier and were told to ignore. This, a fuel filler cap, installed in the wrong place, too close to the engine exhaust manifold. In flight, that heat is manageable. On the ground, idling, the exhaust sits directly beneath the filler. If there's even a tiny leak, just a few drops of 100-octane aviation fuel, it vaporizes, ignites, and spreads. The crew notices it immediately. Smoke, then flames. They abort, but it's too late. The fire spreads to the fuel tank. The tank ruptures. The bomber disintegrates, flaming wreckage scatters across the airfield. 10 crew members die instantly. The fire spreads to a nearby building, Boeing's packing plant. 20 workers on the ground are killed. Dozens more are injured. This wasn't a combat loss. This wasn't sabotage. This was a design flaw that Boeing knew about and the Army Air Forces greenlit anyway. The chief test pilot, Edmund T. Allen, one of the most experienced aviators in the world, died trying to land a plane that should never have left the ground. And the Pentagon's response? Redesign the fuel system, but keep building, keep flying, because the war couldn't wait. And then there's the P-39, the plane that could have been a legend and instead became a cautionary tale about bureaucratic sabotage. Bell designed the Airacobra around a single idea: put the engine behind the pilot. This allowed a 37mm cannon to fire through the propeller hub, devastating firepower. And with a turbocharger, this thing was supposed to dominate at high altitude. But in late-stage development, someone at the Army Air Corps made a decision that would cripple the entire program. They removed the turbocharger. Why? Weight savings, cost, production timelines. Pick your excuse. The result? A fighter with excellent low-altitude maneuverability and absolutely useless performance above 15,000 feet, which is exactly where it needed to meet Luftwaffe fighters over Europe. American pilots never got the high-altitude fighter they were promised. Instead, they got a plane that excelled at one thing: ground attack in the Pacific. The Soviets, who received thousands through Lend-Lease, loved it for low-level combat. But for US pilots fighting the air war over Germany, we asked for a Mustang, they gave us a tractor with wings. Alright, so what happened? Did these planes stay grounded? Did they fade into obscurity? No, they got fixed, eventually. The Corsair, Vought, and the Navy finally listened to the pilots. They strengthened the landing gear, redesigned the flaps to reduce bounce on touchdown, extended the tailwheel strut to improve the pilot's angle of view, and most importantly, they raised the entire cockpit 2 inches. Those 2 inches gave pilots just enough visibility to see the deck on final approach. It wasn't perfect, but it was survivable. By late 1944, the Corsair was back on carriers, and it became exactly what it was supposed to be: a dominant fighter. It racked up an 11-to-1 kill ratio in the Pacific. Pilots who survived the early days swore by it. Once they fixed the gear, this thing was a beast. I'd take a Corsair over anything Japan had. The Marauder, same story, different fix. Wright Field test pilots finally intervened. They developed comprehensive engine-out training protocols. Crews learned to handle asymmetric thrust. They practiced single-engine landings until it became muscle memory. The accident rate plummeted. By 1944, the B-26 had the lowest loss rate of any American bomber in Europe. The Widowmaker became one of the safest planes in the sky. Not because the plane changed, because the training did. Crews who flew it in combat, they loved it. It was fast, tough, and accurate. But none of that erases the men who died in training while brass ignored the warnings. The B-29? After the Seattle disaster, Boeing redesigned the entire fuel system, moved the filler caps, rerouted fuel lines, added fire suppression systems. It worked. The B-29 became the most effective strategic bomber of the war. It firebombed Tokyo. It dropped the atomic bombs on Hiroshima and Nagasaki. It ended the war. But 30 people died, so Boeing could learn a lesson they should have learned in the design phase. And the P-39? The Soviets made it legendary. They used it for low-altitude combat, tank busting, ground attack, close air support, and it excelled. Soviet ace Alexander Pokrishkin scored 59 kills in a P-39. But American pilots? They never got the high-altitude fighter the Army promised. That didn't come until the P-51 Mustang. By then, it was too late for the men who flew the Airacobra over Europe. So here's the truth. These planes aren't legends despite their flaws. They're legends because the men who flew them survived long enough to make them work. The Corsair killed pilots in training, then dominated the Pacific. The Marauder was a widowmaker, then became the safest bomber in Europe. The B-29 incinerated its own factory, then ended the war. The P-39 was sabotaged by bureaucrats, then became a Soviet legend. But every one of these planes had one thing in common. Brass knew there were problems, and they sent men up anyway. 165 accidents per 100,000 flight hours. 30 dead in a preventable explosion. This airplane is going to kill me. The question isn't whether these planes were good. The question is, how many men had to die before anyone listened? So I want to hear from you. If you were an engineer in 1942 and you knew your plane had a fatal flaw, but high command told you to keep building, what would you do? Would you blow the whistle, or would you trust the system to fix itself? Drop your answer in the comments. And if you want more stories about the gear that wasn't supposed to fail, but did, hit subscribe.